Everybody, and thank you for joining us today for our Insulation Intel webinar, GWP, ODP, and Next Generation Spray Foams, Understanding the Evolutions. My name is Kim Melton, and I'm going to be the moderator for today's presentation. Before we dive into introductions, I do want to go over a few logistics. First and foremost, like many of you, we are still working from home. So if we run into any technical difficulties that are prohibitive to the presentation or disruptive to the presentation, we'll pause the presentation for up to 5 minutes. If we cannot correct the problem within that period of time, we'll cancel today's presentation and send you a new invitation or recording depending on where we are in the presentation itself. Also, we'll be having a live Q&A today after the webinar, so if you have any questions, you can submit that via the Q&A feature, and you should see that to the right side of your screen. If you don't see a Q&A dialog box on the right side of your screen, you can click on the small ellipsis in the bottom right-hand corner. That's going to open up a Q&A option for you to click, and that'll open the dialog box that you can use to submit your questions. Additionally, this webinar is for educational purposes only and should not be used as a substitute for professional engineering design, consultation, or documentation that may be required by your building codes, contracts, or applicable laws. So if you have any questions about this after the webinar, you can refer to our specific application guidelines and instructions, and those are located in the product sections of our website, or you can reach out to us directly. Also, we're going to follow today's webinar with a survey, and this is your opportunity to provide us with feedback on how we've done today. You can use it to ask any additional questions you may have about the topic of today's webinar, or you can even suggest new topics for future webinars. And this survey is really part of how we deliver the JM experience to you. Now, the JM experience is based on 4 pillars of the JM culture, and those are listed in the bottom left corner of your screen there. And basically, it's critical to us to make sure that we hear and understand and respond to your needs in order to deliver the best interaction to you. And this survey allows us to do that. So it's not just a one-way street where we're giving you information. If you have feedback on how we've done or suggestions on how we can improve, that would be great, and we'd love to hear it. Also, we're frequently asked whether or not we send out these presentations upon their conclusion. We do not send out the presentation itself or PDF of the presentation, but we will post a recording of it online for you to watch at your leisure or share with your colleagues. And the reason we do this is we want to ensure that you have the presentation within its full context. So we'll send an email to you with a link to the presentation once it's live on our website. So with that, we're going to get into some introductions with our hosts today. Joining me is Chanel Charbonneau and Wyatt Stevens, and I'm going to turn it over to them to introduce themselves.
Thanks, Kim. Yeah, I'm Chanel Charbonneau. I am the product engineer for spray foam at JM, really focusing on product development. I'll hand it over to Wyatt.
Thanks, Chanel. Wyatt Stevens, our senior lead technical specialist for in the field, handling spray foam products as well as our other products within our portfolio. So yeah, we just wanted to delve in and talk a little bit about spray foam insulation, and specifically today we're talking about the difference between 3rd and 4th generation refrigerants. But what we did want to do is just go ahead and acknowledge the elephant in the room, as most of the people on this phone are well aware of supply constraints and are sitting there just wondering, well, what about that? So we just want to go ahead and right up front acknowledge sort of how we got here, what's going on. What you see here is that in late 2020, we had a significant increase in single-family housing starts and even some of the other aspects, whether it be multifamily or commercial, but that significant increase occurred right at the same time that we had 5 major hurricanes in the Q3 of 2020. Those hurricanes interrupted ISO supply for a number of the ISO manufacturers. And then right on the heels of that, we had the COVID issues that propped up by creating port issues and the ability to get imports in, get the exports out. And then ultimately, right as those 2 things were starting to correct a little bit, we had these historic storms that were just recently that resulted in 2 weeks or so of interrupted supply and the ability to manufacture for 2 or 3 of those ISO suppliers. And the end result of that is we have a significant ISO shortage. It's a global issue. It's not going to rectify anytime in the absolute near future, and even beyond the ISO supply, we're now experiencing issues with some of the raw materials that are utilized in the B sides of the spray foam, and those are going to continue in through probably Q3 and just wanted to go ahead and acknowledge it before we jumped into the actual reason for the webinar, as many people are wondering about that. So just talk a little bit about the components of spray polyurethane foam. As many of the people on the phone know, on the left-hand side here, we have a drum of isocyanate, sometimes referred to A side, MDI, PMDI. This is 50% of the composition, and it is not polyurethane, it is just the isocyanate. And when we combine that A side with the B side, shown here in the purple drum, sometimes referred to as resin or polyol, the two products come together through a proportioner that you guys will utilize, and that proportioner obviously preheats those chemicals to ranges of 120, 130 degrees. Those materials are ran down a high pressure hose where ultimately they land at the gun that you see there at the end of the hose, and those two products are mixed at 1,000 PSI. That impingement mix and the culmination of those two different chemical units is when the polyurethane compound is created, and that's when spray foam becomes insulation and is installed into the wall. There are really two types of spray foam. We have open cell and closed cell. And in the open cell, what you see in the microscopic illustration there is you see the hard lines that are referred to as struts. And the significant difference that you see in open cell spray foam is that the window that would exist between those struts that you see on the microscopic image on the right, the image on the left, those windows are not in place. They're either disrupted, they're gone, they're not intact. And so in open cell spray foam, we have this cell matrix that does a really, really great job of kind of minimizing heat transfer and air movement. However, the cells are open, and so it doesn't trap or harness any gases specifically within the cell. Then when we move into closed cell spray foam, in closed cell spray foam, you see those same struts. Obviously, the image is quite a bit further out, but you can see that the windows between those struts are intact. That allows us the ability to harness or trap refrigerant within each of those cells. And it is the refrigerant that creates the high R value or the reduced thermal conductivity of the spray foam. When we talk about open cell versus closed cell, over on the open cell, we have what we call generically or a nominal half-pound density. That's to say that the open cell spray foams kind of go in a half-pound per cubic foot family. That density might actually range anywhere from 0.4 up to 0.75, but the key is that the cells are open and that they're referred to as half-pound foams, not that they're specifically a half-pound foam. They are referred to as a water-blown foam. Chanel will expand on that a little bit here later. They do have decent sound dampening. Our values are pretty comparable to fiberglass. There may be a tad less, however, they do have the air barrier properties. And bottom line is they're R13 and 2x4, R19, 2x6, pretty much the same as fiberglass. They are not vapor retarders, but they do expand radically, fill every kind of nook and cranny void, and do a great job of insulating. Over on the closed cell foam, which is really kind of why we're here to talk about today, in closed cell foam, we're going to talk more about the fact that we have Generation 3 and Generation 4 HFC refrigerants, Hfo refrigerants. A couple of key points we want to talk about right now is that the closed cell spray foams do have that high R value, something in the neighborhood of 7 per inch. They are air barriers at low thicknesses. They don't require a full cavity fill to achieve an air barrier, nor do they require a full cavity fill to achieve an actual vapor retarder. They do result in increased strength of the structure, something in the neighborhood of 200, 300, even 400%, just kind of really depends on what it was starting with. As mentioned, the open cell foam has good acoustical control. It is the air barrier. Closed cell foam does not have good acoustical control. If that's ever been purported, we'd just tell you that the closed cell spray foam, it's a closed cell, so it tends to reverberate sound, not absorb it, but it does have that high excellent R value. And then we'll move over to Chanel to talk about the blowing agents.
Thanks, Wyatt. Yeah, so as Wyatt said, I'll talk some more about blowing agents, why they're important, how they affect spray foams, and then also how they have changed over the years. A blowing agent is a liquid component of spray foam B-side that undergoes a physical or chemical change during application that transforms the polyurethane from an extremely dense solid into a foam. Blowing agents are what gives spray foam its thermally insulating properties. And then there's two types of blowing agents, and these are best classified based on what type of reaction is occurring. Chemical blowing agents react with the A side to form bubbles, which forms the foam. The main chemical blowing agent is water, which forms carbon dioxide bubbles to expand it. While water is typically used in both open and closed cell, open cell generally uses water alone, and closed cell only uses a small amount of it. Carbon dioxide is much less thermally insulating than a physical blowing agent, which is why open cell has that much lower R value than closed cell. Closed cell, on the other hand, uses that physical blowing agent to provide its thermal insulation. Physical blowing agents, unlike chemical ones, do not undergo a chemical change at all to form the bubbles in the foam like water does. Instead, they simply boil at temperatures that are lower than typical spray foam processing parameters, meaning that they're changing from a liquid to a gas when the B side is heated as it goes through the proportioner. Since all it takes for a physical blowing agent to change from a liquid to a gas is heat, that can happen without being combined with the A side at all. And that's why you don't want to recirculate closed cell B side, especially if the hose or proportioner is heated up. You're going to lose blowing agent and negatively impact your foam. So physical blowing agent use has changed over the years, and let's walk through these changes and why they've occurred. Even though there are several types of physical blowing agents, the spray foam industry groups them into generations. The first generation of blowing agents used in spray foam were CFCs, or chlorofluorocarbons. These had a high ozone depletion potential, and they were banned in 1996. The second generation was hydrofluorofluorocarbons, or HCFCs. These also had a medium-high ozone depletion potential, and therefore they were banned in 2005. The third generation of blowing agents is still in use in most U.S. states today, and was only recently phased out in some states and in Canada. These are HFCs, or hydrofluorocarbons. HFCs have no ozone depletion potential, but they do have a high global warming potential, which we'll talk more about later. Corbon 3 is JM's high-performing third-generation offering. So the newest generation of blowing agents are called hydrofluoroolefins, or HFOs. These have 0 ODP and a low GWP, which is similar to that of carbon dioxide. They're a replacement for third-gen in states and countries with the HFC bans in place. And JM Corbon 4 was created to match Corbon 3's performance, and really without that global warming potential. So what are global warming potential and ozone depletion potential? Global warming potential is determined by comparing how much energy 1 ton of a gas will absorb to the amount of energy 1 ton of carbon dioxide will absorb over the same time period. So this is a measurement that allows us to compare the impact of different gases in the atmosphere compared to that reference gas of CO2. CO2 has a GWP of 1 regardless of the time period being measured, and then gases that have a larger GWP have a greater potential to warm the earth than carbon dioxide. There's 3 things that impact a gas's GWP. These are its ability to hold heat energy, the gas's lifetime in the atmosphere, and the volume of it in the atmosphere. So how does spray foam have a GWP at all when the gas is trapped inside the cells? Well, firstly, not all of the gas in the B side actually makes it into the foam. A little bit of it is lost during spraying when the A and B side mixture is being atomized in the air between the spray gun and the substrate. Also, if spray foam is of poor quality and has a high proportion of open cells, blowing agent can actually diffuse out of these cells. This is why it's really important to spray for optimal quality, using a technique such as multiple immediate pass that minimizes that proportion of open cells and keeps most of your blowing agent inside the foam. Loss of blowing agent doesn't just harm the atmosphere, it also harms R value. So why is GWP so important? As a high-performing insulation and air sealer that maximizes the energy efficiency of a building, spray foam is already a product of choice for architects, builders, contractors, and homeowners wanting to minimize their environmental impact. Reducing global warming potential is another big step in that direction. Additionally, as states and countries work to combat global warming, blowing agents with high GWP are being phased out, including the HFCs that many spray foams use. And that impacts all third-gen closed cell spray foams. For more information on the states and countries that have either phased out or are developing restrictions phasing out HFCs, this map from the American Chemistry Council is a really great resource since these regulations are constantly changing and restrictions can go under effect very quickly. Additionally, a ban at the federal level in the U.S. is currently under development. That timeline is not set in stone yet, but we can expect that to go into effect in 2036 or perhaps even earlier. So what are the actual differences between HFC and HFO blown spray foams, and what are their global warming potentials? HFCs, such as those used in Corbon 3, have a GWP of 800 to 1200, and HFOs, such as those used in JAM Corbon 4, have a much lower GWP of around 2. Lastly, what about ozone depletion potential? Is that still a concern? So these chemicals that do have a high potential to deplete the ozone layer were completely phased out of spray foams in the US in 2005. And since then, spray foam has been made with zero ozone depletion potential blowing agents. So this is really behind us, and the conversation has really moved on to global warming potential. So let's take a deeper dive into the performance characteristics of third generation versus fourth generation spray foams. To start off with, let's look at Corbon 4 versus Corbon 3. JAM has developed Corbon 4 to be remarkably similar to Corbon 3 in terms of both sprayability and physical performance. Also, very importantly, yield is equivalent to or better than Corbon 3, and that's something that many fourth-gen foams have struggled with, and therefore was really a point of focus for our development. Other similarities are excellent cold weather application performance, single pass thickness, the ability to apply in multiple immediate passes, and the thermal performance of Corbon 4 US. The only two differences are a minor change to processing parameters, which Wyatt will talk more about later, and the thermal performance of Corbon 4 Canada, and I'll talk about that next. So why does Corbon 4 Canada, as well as many Canadian spray foams, have different thermal properties than those in the US? The standard for thermal testing in the US and Canada is actually pretty different. The US uses ASTM C518, while Canada uses CAN ULC S770 LTTR, which stands for long-term thermal resistance. They use the same apparatus, but the sample preparation is significantly different. C518 testing is performed and reported at a 1 inch and a 3.5 inch thick sample, and it occurs after 180 days of aging at lab conditions. This data is then reported as R per inch. In contrast, LTTR involves cutting a sample into thin slices of around 10 millimeters to age a sample much faster, and is predicting thermal performance after 5 years instead of 6 months. And then that data is then reported as RSI at 50 millimeters. In general, when it's converted to R value, LTTR is lower than C518, somewhere in the neighborhood of 0.5 to 1 per inch, and sometimes even more than that. This is because it's reflecting thermal insulation power after 5 years, and C518 is only looking at the first 6 months of aging. Most of that does occur in those 6 months, but some does continue to happen after, and the rate at which your R value loss occurs does depend on the product, and that kind of final R value that you get where it achieves steady state could occur at the 5 years, but also before or after. There are a couple more details to LTTR that are critical for understanding the test and the thermal performance. This test method itself has undergone changes since its original adoption. The sample preparation used in the 2003 standard, for instance, generally produces a better R value than in the 2009 standard. The RSI reported on a product's data sheet is based on the test method in use when the product was first qualified. So a product tested before the 2009 standard was adopted might have a higher R value than if the exact same foam was tested in accordance with the 2009 standard. For that reason, you might see both the 03 and 09 standards reported on a data sheet. Corbon 4 Canada is on the 09 standard. So what about type 1 versus type 2 in Canada? All these types really mean is that a foam has an RSI of less than 2.0 or above 2.0 at 50 millimeters. So a type 1 foam simply requires more of it to be installed to reach the same total thermal performance as a type 2 foam. For example, say you have a 2x6 wall that requires a total R value of 28. A type 2 foam with an RSI of 2.0 would require 4.9 inches of foam, while a type 1 foam with an RSI of 1.8 would require 5.5 inches of foam. With these new standards producing lower and lower LTCR values across the board, fewer spray foams are considered type 2 now than they used to be. And all this means is that more foam must be applied to get the same total thermal performance. There's nothing inherently different between type 1 and type 2 foams besides that R per inch. And a type 1 foam might perform equal or better to a type 2 foam when applied at the appropriate thickness for equivalent R value. So lastly, let's look at a comparison between a competitive Gen 3 versus Gen 4 product just to explain some of the challenges with the HFC to HFO transition that some of you might be familiar with. Though it does have equivalent thermal performance, the Gen 4 product has a higher density and a higher rate of change for dimensional stability. Higher density translates to lower yield, and increased variance in dimensional stability increases the potential for the foam to possibly crack off the framing, damage the substrate, and compromise your air and vapor barrier. Issues like this are why JM has developed Corbon 4 to be equivalent in performance and in yield to Corbon 3. So now I'll pass it back over to Wyatt to talk about the installation differences between the products.
Thank you, Chanel. So as mentioned by Chanel there, we did go through a painstaking process. We certainly weren't first to market with a fourth generation spray foam. JM's a very risk adverse company, and we were holding out for improved raw materials to create the best possible fourth generation spray foam, and that was done in mind with the fact that that product had to perform as good as or better than Corbon 3. I'm not going to tell you that we're actually 100% there, but we're certainly 95% there, and we'll continue to work to create a finished product that in the end outperforms even any third generation spray foam on the market, much similar to what we went through back in 2005 as third generations came in place over second. So just to talk about the good news on the home front currently is that JM Corbon 4 does spray and perform very similarly to Corbon 3. The first and largest thing that an applicator will notice is that the Corbon 4 is a tad slower on reactivity profile. And that's going to require that we offset that chemical heat aspect of this deal with a little bit of mechanical heat. And so if you're transitioning from Corbon 3 into Corbon 4, you'll need to move your processing parameters up about 10 degrees. Your A side, B side hose, whether you're running a temperature split as illustrated here, or you're running the same temperature across the board, whatever you're currently doing there, just plan on moving up about 10 degrees to help offset that mildly slower reactivity profile. But again, through mechanical change, it could be unnoticeable. And then with Corbon 4, it really does spray very much like Corbon 3. We wanted to take a minute and address the aspect of what is the maximum allowed pass thickness. And there are two key terms that JM lands on. One here would be pass thickness or what's your maximum pass, and then the other is single sitting. So single pass versus single sitting approach. In a single pass, we're saying that the applicator is going to apply enough liquid that the foam grows to be X thickness. And with Corbon 4, you can apply enough liquid in a single pass to grow to be 4 inches thick, and that's fine. Following that, you would need to have adequate cooling before you applied anything further. And so you might take that approach if it's a 4-inch finished thickness job. However, if you have a 5-inch, a 6-inch, a 7-inch thick job, if you're doing walls, it makes all the sense in the world on a 7-inch job, as an example, to go around that building twice and do 3.5 inches on each pass. That's going to give you the maximum yield. This is not unique to Corbon 3. This is the reality, or Corbon 4 rather. It is the reality of all closed cell spray foams. There is a density gradient associated with pass thickness, and if you want to achieve maximum yield, then you'll need to push towards the maximum allowed thickness. However, there's some concerns as you do that. In the image, you see a foam that is showing where that foam applied at a thickness of around 5.5, 6 inches thick in a single pass is exhibiting some dimensional stability issues. And what happens when you push a foam into a 5 and 6 inch thick pass, it starts to reduce the density well below having enough plastic left to sustain the normal cyclic nature of every day that foam is heating and cooling with nighttime, daytime. And as we all know, we have thermal expansion and thermal contraction associated with that temperature change. And when you push the density low or you push the thickness high, the density gets low enough, you just don't have enough plastic left to sustain that, and you could end up having some long-term dimensional stability as shown here. On the right-hand side of that image, you see that exact same foam applied in 3 uniform passes. There's no cooling time between these passes. This is just used to increase the amount of plastic, increase the in-place density. Yes, that results in a decrease in yield. In this example, that particular foam thickness could have been achieved with 2 passes. However, there would have had to been something in the neighborhood of 25 or 30 minutes of cooling time between those 2 passes. And so what we're doing is taking a single sitting approach and saying, all right, if I'm not climbing through the trusses, 1, there's a safety component, 2, there's a time and labor component, and the fact is we don't want to necessarily climb through the trusses twice. And in that instance, if you have a job up to 7 inches in total thickness, you can apply that 7 inches in a single sitting before moving on throughout the attic assembly. That would be done in the case of 7 inches by applying 4 approximately uniform passes of 1.75 inches thick. So you can see here in the chart, 4 inches in a single pass, and then if you take that 5, 6, and 7, that's in 2, 3, or 4 passes. And then we want to just talk about JM Tech Connect. That is a team of members. We are online, we're on call, we're on site, we're working with you guys. We're here and available to help with application, installation, building science, equipment maintenance, setup, et cetera, et cetera. We want to make sure that you guys know that team's here and available to JM customers. Here you see different points of contact depending on where you're geographically located. This chart is available on jm.com/spray if you need to look up the tech rep specific to your area. And then we also have JM Specifier Services. This is a team of individuals that are there to work directly with architects, specifiers, and designers. If you have a spec that you're up against where JM Corbon is not specified, then we have a team that helps rectify those specifications or show equivalent performance. And that team's also available to you. And then we also have our parts and equipment department. Damon runs the parts and equipment. We are a top tier Graco distributor as well as a PMC distributor. And we have all of those needs from rig building to replacement parts to equipment maintenance parts. And he can be reached at the phone number shown there, also available on jm.com/spray. And with that, I'll turn back over to Kim.
All right, thank you so much, Wyatt. So I do want to talk about a couple of additional resources that we have available for anybody who's looking for more information or just online resources to help you better understand insulation, everything, and everything related to it. So the first one I want to talk about is the source. And this is our online building insulation resource library. It is where we host all of our recorded webinars, including this one. You'll have access to our latest blog, as well as descriptions of our products, all of our technical documentation, online tools and trainings that are available. And really, this is an educational repository available to make sure that you have access to all of the information you need about insulation. Now, for those of you who are on job sites, I'd like to recommend the JM Smart Binder. This is an app for smartphones, and basically it gives you access to JM's technical documentation that you need on the job. So you're talking about data sheets, you're talking about SDSs, installation materials, that sort of information is all going to be there in JM Smart Binder, and you can just download that right from the Apple Store or the Android App Store. So also, as Wyatt mentioned, we do have Tech Connect. This is for JM customers who need additional information, and this applies to anybody who's doing specifications, anybody who's doing installations. There's a variety of resources there, and I just wanted to put this online for anybody who would like to reach out to us specifically and get further information on that. And then finally, for everybody who attended today, you will get a certificate of completion. One thing to note, this is not an AIA certified webinar. We talked about JM specific products in it, and as a result, we can't get AIA certification on this webinar. But you will get a certificate of completion, and you can submit that to your continuing education governing body to see if they will accept it as as credits for continuing education. So with that, we're going to launch into some questions. There were a number of questions submitted that we're actually going to follow up with offline because they don't either apply to today's topic, or they talk about pricing, that sort of thing. So those are not questions that we address publicly, but we do have a lot to get through today. So with that, we're going to kick things off. The first question is for Wyatt, and that is, can manufacturers jointly require contractor knowledge on density testing with spray foam applications?
Sure. So I think to answer the question two ways. One, when we say contractor knowledge, I'd like to think that chemical suppliers are currently incorporating certainly contractor knowledge on density. With respect to Canada, Canada has a governmental regulation requirement, and spray foam is a licensed trade in Canada, and density checks are required twice per day on every single job. They have to have spray logs that are handed in and tracked and done that way. In the U.S., it is not a licensed trade. We could argue about whether or not it should be. The fact is, it's very, very difficult to back up that horse. And there's currently nothing on the horizon that's going to result in a industry managed, accumulating or tracking density checking or having some sort of governmental regulation around that. But I would like to think that your chemical supplier, if it's not us, is certainly helping you understand how that density is impacted, what your spray techniques do to impact that density, and how it affects you, and how to properly check density. Hopefully that answers the question.
All right, thank you, Wyatt. The next question we have is for you, Chanel, and that is closed cell third-gen spray foam being phased out in New Jersey, and what should we use in cathedral ceilings?
Yeah, so third-gen was actually phased out in New Jersey last year in July. So New Jersey has been on fourth-gen for, I guess, coming up on a year now. And then in terms of cathedral ceilings, really depending on where this home is located in the climate zone, either open cell or closed cell could be good. It's really just dependent on design of the actual R value.
All right, thank you. The next question is for you, Wyatt, and that is, when you're applying insulation to the exterior of buildings, it reduces energy consumption by 70%, and this fact should create an industry plus jumpstart to the green revolution. Is there any movement toward insulating homes on the exterior?
Right, absolutely. 100% agree. Continuous insulation has a magnitude of benefits and impacts beyond cavity fill insulation. interestingly enough, that was addressed and quite frankly written as what assumably was going to be a requirement and become a standard building practice in, I think it was the 2015 IECC, International Energy Conservation Code. JM actually came to market with a multitude of products specifically for addressing the continuous insulation requirement. We have different boards for that. We certainly subscribe to the use of spray foam for that. We even have some uses of mineral wool for continuous insulation. However, bottom line reality is that today there seems to be no enforcement with respect to that change in the IECC code. There are building difficulties around the use of continuous insulation, whether it be how to handle not having wood to nail certain exterior sheathings to, whether it be the fact that door and window transitions are no longer feasible, as when you go into Home Depot and you buy a pre-hung door, it's made for a 2x4 or a 2x6 wall. It's not made for a 2x4 wall plus an inch of continuous insulation. And so I guess I'm going to answer the question that no, there doesn't seem to be any significant jump and directional change in the insulation industry to incorporate the use of CI, and that we're anxiously awaiting for that to occur, but certainly aren't able to direct the industry.
All right, thank you, Wyatt. The next question is for you, Chanel, and that is, does the latest spray foam insulation require a fire protection layer? And I just want to preface this, we will only speak to Corbon 4 in this case, not other materials in the market.
Yeah, so in terms of fire protection, 3rd gen and 4th gen, there really hasn't been any changes there. They're still required to meet the same like building code acceptance criteria. So they are still required to be protected from occupied space by that 1/2-inch gypsum board or a fireproofing coating. So that has not changed between 3rd and 4th gens. As far as other newer spray foams go, that's not really something that JM can talk to.
All right, thank you. The next question is for you, Wyatt, and that is, what are the recommendations for ventilating after the application of foam to eliminate any toxic chemicals in the air?
Sure. So, you know, it's a relatively easy question, and at the same time, it's a difficult question. There is the standard subscribed to position with respect to spray foam and its installation in structures that other trades do not enter the structure for 12 hours, that building occupants do not enter the structure for 24 hours. It's rarely ever a problem. Typically, spray foam contractors wrap up at 6 p.m. The rest of the folks show up the next day at 6 a.m. With respect to ventilation and how that might be achieved, there's an EPA ventilation guidance document. I can't point you to a specific URL. It's EPA ventilation guidance designed for the environment. I would reference to that document on best practices for achieving ventilation. It talks about makeup air as well as exhaust air, how to achieve cross ventilation, how to create cordoned off areas in which to work so that you have, you know, specifically lower areas or smaller areas to work in.
All right, thank you. Chanel, is there anything you'd like to add to that?
Nope, that sounds good to me.
Okay, excellent. Well, the next question is also for you, and it simply says recyclability ? So can you speak a little bit to that?
Yeah, so I assume that means recycled content of the foam before it's applied and not ripping it out and trying to recycle it. But there's many spray foam B-sides, more on the closed cell side, that have some recycled content in their polyol. Corbon 3 and Corbon 4 are one of those. B-side recycled content is 11%, which will give you that 5.5% in your finished foam, but that varies among different manufacturers.
Excellent, thank you. Wyatt, the next question is for you, and that is, if open cell is an air barrier, why does it also not have vapor barrier characteristics?
Okay, sure. So when you talk about air movement is very different than talking about diffusion. And so air movement, let's just say that something's blasting directly against it, and then its ability to shield that, we'll call it in the moment. Whereas when we talk about vapor permeability, we're talking about vapor diffusion, something that occurs where we've got a lack of equilibrium on two sides of some sort of assembly. And the reality of the world that we live in is that everything's always trying to balance. So if you have 18% humidity inside and you have 50% humidity outside, those two environments are trying to equilibrate, and so that there's a vapor drive associated with that. Warm is always seeking cold, and then warm air tends to hold more moisture than does cold air, and so that change occurs in that temperature. You're going to have a vapor drive associated with that. And when we talk about diffusion, we're talking about something that just happens over X course of time. And so when we're talking about vapor retarders, we're talking about the ability of XYZ product to retard that diffusion of vapor. Obviously, we're all familiar with something like 6 mil plastic that's a class 1 vapor retarder and just stops vapor diffusion or stops vapor movement when it collides with that membrane, as opposed to something like closed cell spray foam that would be a class 2 vapor retarder. And is certainly still doing significant amount of work to retard the diffusion of vapor, but it's not a class 1 retarder. But yeah, it's just two very different characteristics versus kind of in the moment versus diffusion over time.
All right, thank you, Wyatt. The next question we have is, can you spray open cell over closed cell on a piered house that may hold water underneath? So Wyatt, I'll start with you, and then Chanel, if there's anything you want to add to that, please feel free. With
respect to a pier structure, and really we're talking about foam on the underside of the floor more than likely, the high humidity environment, and that the incorporation of open cell spray foam that could ultimately collide with what might be a condensing surface on the spray foam on the closed cell side is really just not a good application in that environment. As far as open cell, closed cell goes, they're perfectly compatible with each other. There's a multitude of environments where open cell spray foam could be a good application over closed cell. If you've already addressed air movement, there's probably no reason for spending extra money on the same R value as fiberglass. So a bib or a bat or something over closed cell might be a better application in those other environments. I wouldn't put fiberglass in a pure structure either on the underside of the floor, but I think in respect to that specific application, I would stick with closed cell spray foam only.
Excellent. Thank you so much, Wyatt. The next question, Chanel, maybe you can speak to this one, and that is, I previously used 1 inch of closed cell spray foam for a vapor retarder. Is it now 1.5 inches?
So 1.5 inches is really across the board what we consider to be a type 2 vapor retarder for a closed cell. I'm not sure if literature used to recommend 1 inch, but at least the way that it's currently tested, ASTM E96 is the test. Generally, you're going to get 1.5 inches to get that less than 1 perm.
All right, thank you. Chanel, next question is also for you, and that is, are blowing agents different than refrigerants? If HFO has a GWP of less than 2, is it effective as a refrigerant?
Yeah, so at least in the spray foam industry, blowing agent and refrigerant are pretty much used interchangeably. And the global warming potential is not related to how well it thermally insulates at all. They're really just, two kind of separate things. So a lower GWP does not translate to a lower R value.
All right, thank you. The next question for you, Chanel, refers back to your slide on R values versus LTTR. And the question was, are these nominal R values as opposed to effective R values?
That's correct. These are R values as measured by ASTM C518. I assume by effective, they mean like an overall wall U value, which would be an assembly test versus a product test like C518. So your effective R value would be based on a whole host of different things. not just the R value of the foam. It would be, what type of framing, the framing fraction, stuff like that. So yeah, the ones that we've listed and the ones that you'll see on data sheets are just the product test, not the assembly test.
All right, thank you. We did have a couple questions coming through about the name of the app, and that is James Smart Finder. It's listed right here on your screen. And then also another question about whether or not we'll send out a recording of the presentation, and that is yes. You can look for that in your inbox next week. So for anybody who's curious about that, please keep an eye out for it. Our next question for the panelists is the chart that noted the application that could cause framing distortion. So Wyatt, this is for you. So the chart that noted the application that could cause framing distortion or damage, which type of insulation was this talking about? And that was type as in type 1 or 2, not type as in the brand.
So I guess this chart that noted application could cause framing distortion or damage. I suspect that the individual has dealt with an instance in the past where a foam that was not dimensionally stable resulted in probably pulling of stud members, which is exactly the purpose behind the single pass versus single sitting aspect of the chart, and creating a foam that is dimensionally stable. And I think what they're saying there is that, hey, when I hear you talk about doing 4, 5, 6, 7 inches, that may cause framing distortion, which would be the purpose behind doing the multi-pass. And other than that, the type open cell foam would never cause framing distortion, so it would be in reference to closed cell.
All right, thank you. Chanel, is there anything, sure, is there anything you'd add to that comment?
Not really, no.
All right, thank you. The next question is for you, Chanel, and that is, with respect to flammability, how toxic is the spray foam insulation?
So spray foam has to be rated to ASTM E84 Class 1, which is 25 flame spread and 450 smoke. So spray foam is flammable, and it does have to hit that classification. But in addition to that, it does have to be separated from occupied space by that 1/2-inch gypsum or a fire barrier coating. So even if it is in a fire situation, the intention of the code requirements for either the gypsum or the coating are to be able to get people out. And in terms of like toxicity testing for spray foam fires, that's not really something that I'm aware of. It might be, there might be some research on it somewhere, but that's not something that I have a lot of knowledge on off the top of my head.
All right, thank you. Wyatt, the next question is for you, and that is, what is the best way to confirm foam depth after the foam is dry if it's not equal to the framing members?
I've seen everything under the sun used for a depth gauge. I think the bottom line is you're looking for something as small in diameter as possible, and something that's relatively rigid from a wire perspective. There are legitimate depth gauges out there available. They use a small pin, and they have a slide ruler on them. I've seen guys take landscape flags, and they'll take the landscape flags, which the flags are fixed on, and they'll set them up in a chop saw, and they'll lop off green flags at 2 inches and orange flags at 3 inches and pink flags at 4 inches, and then they have these flags on their truck and basically have disposable 2, 3, 4 inch depth gauges. But I think the bottom line is you're really looking for something that's as small in diameter as possible and rigid enough wire that it will poke to the rear. And then if I can back up to that last question on smoke toxicity, it's a question that's always difficult. And the fact is, I just want to remind everybody in the audience, there's no such thing as safe smoke. If it's burning and there's smoke, it's toxic, including cigarettes, right? There's just no such thing as safe smoke.
Excellent, thank you, Wyatt. That's a good reminder for all of us. So the next question we get is, this is for you, Wyatt, and that is, I still get questions from building inspectors regarding the separation of spray foam insulation from wood studs, thereby creating an issue for the vapor barrier. Is this now essentially solved by the product improvement and the changes in how it is applied?
And separation of spray foam insulation from wood studs. You know, I'm sorry, Kim, the wording of the question is not going to be something that I feel like I can adequately address. The foam is not separated from the wood studs. The foam's in direct contact with the wood studs and is imperative to creating a seal.
I think this question is referring to cracking off the wood studs after application.
I guess I'd answer that that's not supposed to happen. that would be the point of using a quality material that doesn't have dimensional stability issues. If it's cracking off the studs, that's a problem. Either it was too cold of an environment during application, or the applications potentially got a problem. The foam should not be cracking off the studs.
Chanel, is there anything you'd like to add to that?
Yeah, just that's why we want to use our smaller pass thicknesses and not really going beyond that, like the density gradient where you're starting to see shrinkage. That's really where you see that. If you're installing it correctly, you know, it's really still a question of installation. It's not only about, you know, product formulation. So even a well-formulated product can pop off studs when you spray it to, you know, way above what the manufacturer recommends, and sometimes that happens. And on the other side, something that says it can be sprayed to 6 inches might look pretty bad at 6 inches, but if you spray it back down at 2 inches, you won't have any problems with it. So it's really kind of finding a sweet spot between both using a really well-formulated foam and spraying it how it is intended to be sprayed, and not trying to push that.
All right, thank you. And I do want to point out to everyone, we'll send you a link to this in a follow-up email, but we have a series of research on specifically what happens when using high-lift foams. And Chanel has addressed it, as has Wyatt during the presentation. And so we'll send you a link to that after the webinar so that you can, if you have any interest in learning more about what happens when you spray foam too thickly, it's a great white paper that talks you through it with some excellent visuals as well. So the next question is for you, Wyatt, and that is, I'm using a 2x6 wall and I want to get the best R value. How much space should be left from the foam to the face of the wall, since closed cell foam can't be trimmed?
Sure. I don't think the question is easily addressed as I want to get the maximum R value. Well, the maximum R value is 5.5 inches in a 2x6 wall. That doesn't mean that 5.5 inches is a optimum level of return. So perhaps it's alluding to that. If I were building my home with 2x6 walls and I try to answer things from the perspective of, hey, how would I do it in my own home? The fact is that 3 inches of closed cell spray foam in exterior walls, perhaps 4 or 5 inches on underside of roof deck, if that's the application, really tends to push to that optimum level of return where, yes, if you put a 4th inch in the wall, yes, if you put a 5th inch in the wall, there are energy savings associated with that 4th and 5th inch, but those energy savings are not very easily offset by the cost of that 4th or 5th inch. And so, you know, 3 inches of closed cell spray foam in an exterior wall really does achieve optimum level of return, and quite frankly, the remaining 2.5 inches of stagnant air has an R value of 2.5. And it could be left there. What's referred to as a near fill would be, hey, we're not going to fill all the way to the face of the studs, but we're going to slightly underfill it, but we want as full as feasibly possible. We'll call that 5 inches of spray foam in a 2x6, an R35, great, R35 US anyway. And yes, you definitely maximized your R value without having to trim, but you probably surpassed the optimum level of return.
All right, thank you so much, Wyatt. The next question that we have refers to, asking for you, Chanel, and that is, Does closed cell, it says, so closed cell foam never becomes a vapor barrier at any thickness. So can you clarify there?
Yeah, so closed cell foam is a vapor barrier once you get to that 1.5 inch thickness. It's just below that you're not going to get the type 2. It'll still be a type 3 is what it's called, but that's not, for code purposes, that's not considered a vapor retarder. So once you get to 1.5 inches, and then obviously anything above that, you would have your type 2 vapor retarder. And actually, kind of depending on the product, you could even get to a class 1 if you really wanted to. You would just have to put in like 10 or 12 inches of closed cell, which you're probably not going to be doing that, but it is theoretically possible.
All right, thank you. The next question we have, Chanel, is for you, and that is, if the thermal characteristics change over 5 years, as per the Canadian test, does this mean that there is still off-gassing for that same period or longer?
So that's a really good question. Just referring to blowing agent diffusing out of the cells very slowly over that 5-year time period. That is true. It's such a small amount of it that once it's behind your gypsum, it's not going to be noticeable at all, and it'll just kind of diffuse into the air and not cause any indoor air quality issues. But a very, very tiny amount of it will be coming out of the foam after your C518 test, and you know, depending on your R value loss curve, kind of depends. Sometime between 6 months and 5 years, or maybe 6-7 years, you'll not see blowing agent diffusing out anymore. But even before that, after the foam is cured, it's not going to be anything noticeable. And then in looking at you know, certain air quality tests, like Green Guard being the main one, that's confirming the fact that there's no VOC or air quality issues based on this very, very small amount of blowing agent that's still diffusing out after it cures.
All right, thank you. So we have time for about one more question, and there are a number of questions we didn't get to today. If we didn't answer your question during the presentation, we'll follow up with you directly afterward. And you can also submit additional questions you may have in the survey, or if you'd like somebody to contact you to talk to you, we'd be happy to do that. Again, here's our JM Tech Connect information as well. So for our final question, this goes back to the supply issue we talked about right at the very beginning. And we actually have our spray foam product manager here, Cassie Tottenhagen. So Cassie, I'm gonna give this one to you, and that is, has there been an estimated time and date as to when the industry expects to recover from the current supply issues, cost, and availability problems? We're required to provide cost estimates with many of our A&E projects, but some are planned for 2023 construction. We need to have an idea of what the industry is recommending for a possible termination date to plan for this continuing market impact.
Yes, of course. I'd be happy to answer this question. So as of right now, our best guess is that we are going to be experiencing supply disruption in some form through the rest of 2021. We recently just released some FAQs that can be shared with our customers if you need documentation to share with your builder or with your customer on understanding the impacts of what's happening. It does include the graphic that was at the beginning of this slide. So what we would recommend that you do is include language in these contracts that protect you in the construction of these materials from both a pricing perspective and an availability perspective. At JM, we're committed to supplying the most material that we can, and unfortunately, this is a result of higher demand than we've ever seen, extreme congestion in the port, so our existing demand can't be fulfilled with U.S. manufacturing capabilities, and then the continued disruption from the storms. One of the manufacturing sites that produces a key raw material in all polyols had over 5,000 leaks at their facility. So it's some pretty unseen conditions that we've seen in the market. And unfortunately, I don't think that I can come and commit to a specific date that it'll be over, but we do expect that there will be some supply restrictions through the rest of 2021 and potentially beyond. But we're committed to communicating as effectively as we can so you can plan for that. And in the meantime, I would make sure that you write your contracts for these large projects in order to protect yourself in the case of future disruption.
All right, thank you, Cassie. So for everyone who attended today, you will be getting a certificate of completion. That should be in your inbox by next Monday. And then we will send out a recording of today's presentation, as well as all the questions we've answered so that you can share it with your colleagues, watch it again, get any information that you may have missed today. Additionally, if we didn't get to your question today, and there were a lot, we will reach out to you directly to make sure you get all your questions answered. So thank you everyone for your time today. We hope you have a great week. And if you have any questions, please reach out to us at the phone number listed on your screen right now. Have a great week.